Okay, this Friday afternoon we are solving polynomial functions using factoring. So, find the zeros of this function and then sketch the function. First thing we can do is see if we can factor it. Alright, so let me write it as 3x to the power 4 minus 6x squared plus 3, and we want that to be 0. We want the output to be 0. So we want to know what values of x, what input values will give me the output 0. In this unprocessed raw form, I don't know what values of x will give me an output 0. So I need to process it a little bit. The processing here is factoring. So with factoring, our goal is always take the GCF out, which is 3. We don't have a variable in the GCF, so we'll just keep it at 3. And we have x to the power 4 minus 2x squared plus 1. Okay. We still cannot know what values of x are going to work. So, in this case, you can notice the exponent 4 is twice this exponent 2. So, as in the last video where we use a special goggles, you can see it as the form a squared minus 2a plus 1. We are familiar with a squared minus 2a plus 1. We are familiar with this form. And we know that a squared minus 2a plus 1 is a minus 1, a minus 1. In the same way, we can write this as what two numbers multiplied give me 1, but when added give me negative 2. And the answer is negative 1 and negative 1. So two numbers that multiply to give me positive 1, but add to give me negative 2. So I have factored this as x squared minus 1 and x squared minus 1. You can check the previous videos for this idea in more detail. Now both of these can be further factored using difference of two squares. So x squared minus 1 is x plus 1 and x minus 1. I will write both of them out. And now you can see in this processed form what values of x are going to satisfy this equation. What values of x can I put in here to get the 0 I want? You can clearly see if I put x as negative 1, I will make this as a 0 and I will get the 0 I want. Doesn't matter what happens to the other ones, right? As long as I have one of them 0. In this case here, we have x equals positive 1. And that will also make this 0. Now notice positive 1 and negative 1 will appear twice. This one and this one will give me a negative 1. This one and this one will give me a positive 1. So I'll make a note saying that they both are double roots. They both are double roots. And I will tell you what that means soon enough. So, when we try to graph, what do we know? We know that these are the roots. What are roots? Roots are the x-intercepts. At x equals minus 1, so here at x equals minus 1, the function has an output of 0. And x equals plus 1, the function has an output 0. So we have 2 points there. The third point that is always very easy is to find the y-intercept. To find the y-intercept, all we do is put in x is 0. So if x is 0, what we are left with is 3, because these two terms fall away. And I know that the y-intercept is 0, 3. So the y-intercept is 0, 3. Now, from our previous knowledge, we know that this is a degree 4 polynomial, degree 4 is even, and we know the lead coefficient is 3, which is a positive number. We know it's positive. So we know that it will look like a parabola, meaning both the arms are going up, and, well, it's a parabola because it's even, so both arms are going in the same direction, and we know the arms are going up because it is a positive lead coefficient. So it's a smiley face parabola. The other piece of information that is up here, it says when you have a double root, it will bounce off the axis. So when a factor is raised to an even power, so this factor is raised to a power of 2, right? Because you have 2 of them, it's a power of 2. This factor here, both of these factors have an even power because there are 2 of them, so it's an even power. So both of them have even powers, both of them are double roots, and because of that, the graph will bounce off the axis. Now there's a lot of information going here. So first I will say I know that the arms are going up. We know that it is going to be a smiley face parabola. And now I'm saying that it is bouncing off the axis because it's a double root. I will go through the y-intercept. I will bounce off the axis and I will go up again. So now you can see I have satisfied all the conditions. So double roots, when you have the same factor twice or any other even power, but for the most part we will only have 2 or maybe 4, but if it's 2, it's an even power. So that means when you have 2 of the factors, it is going to be an even power, which means it's going to bounce off. And when you have it only once, it's going to pass through. All right, so we have solved this problem by factoring.